No, I'm recording. So one is testing concepts, and another is implementation of these testing concepts, and stage three will be tools. So in these testing concepts, what we learn is like all the theoretical part we learn. What is SDLC? What is STLC? Testing methodologies, techniques, static testing, dynamic testing. What is white box testing, black box testing? All these testing techniques and all these things will be learned in stage one. And in stage two, we will implement all these things practically. I'll be showing you how to work on practical website and all those things, and I'll parallelly make you to work on it. And also different types of testing, anything, and how to do a test summary, test closures, all those things. And in stage three, we are going to learn about different tools like agile methodologies, test management tools, and work tracking tools, test cases, if any. Apart from this, I'll be teaching you like performance testing, a JMeter, what is performance testing, different types, and a brief detailed description of performance testing and JMeter, how to use it. And like SQL queries, very basic SQL queries which are required for a manual tester, like update, retrieving data from 2 files, 3 files, like joining them and getting the required data. Resume preparation, manual testing material, website checklist. Website checklist is like when we do a website testing, we need to verify what are all we need to be covered. So the one PDF would be there. I'll provide you that PDF for cross-checking all those things. And interview questions and material, manual testing material. I'll provide you complete material after the end of the batch. And freelancing website. There are a couple of freelancing websites which we can try to work out. If we are successful, we'll be getting some amount. If not, yes, I'll explain you how to do it. I'll explain you how to work on those things. So that is working on freelancing websites is that is not that easy because there are 2 to 3 websites. In first one, we need to write exam. We need to go through some videos and we need to write exam. After that, they will be providing you some website, sample website. If you pass in that, you get good score, then they will assign us some work. So it's a long process, but I'll explain you. If possible, you can work out on it. Okay. So clear to here, Deepak. Hi, Amar.
Hi.
Yeah. So just
Hello.
yeah, Amar.
Yeah, I just joined.
Yeah. So just now I was explaining like basic things of how we do our training. So initially, like in manual testing, I'll be explaining initially some testing concepts, uh, like what is SDLC, STLC testing methodologies, static and dynamic testing, what are different types of functional testings, non-functional testings, all those things are testing concepts. These testing concepts are completely theoretical part. After that, in stage two, we'll be implementing these testing concepts. In practical, I'll explain you how to implement all these things. I'll show you lively how we need to work, and then I'll make you to work live also. I'll make you work live practically, parallelly with me, and later on we'll be dealing with some tools, agile methodologies, test management tools, bug tracking tools, test cases tools, and after that we'll be explaining. You are joined till here from here, I think. So performance testing tools, queries, material. I'll be explaining all these things. Okay. Any questions still here? Anyone? So are you expecting anything more from training, or is okay? So we'll start with as Ammar and Deepak are first. Jay, just bear for some more time. Okay. Just we'll have a recap of what we have in the demo class.
Sure, no problem.
Yeah. So basically, initially we need to understand like what exactly a software is. So what is a software? So software is a set of programs which will perform certain tasks. So when we do some tasks, when we perform certain tasks with a set of programs, it is called as a software. So if anybody in interview, if they ask what is a software, it is a set of programs which will perform certain tasks. So we'll write some programs and we'll execute those things which will perform certain tasks or which will have some action part, which will undergo some action part and perform a task which is called as a software. So how does this develop and what are the requirements, what we do on this? I'll explain. So let's go with an example. For example, we take one bank. Okay, we take a bank. So now a bank want to update its system. They want to go to online. They want to work on a software. So they want to update their banking services, banking system. So what they do is they have approached one IT organization. Bank has approached an IT organization. What the bank has provided all the requirements, what they want exactly. And then this IT company analyze the requirements of the organization, of the requirements of the bank, what they have provided. So now the IT company has understood what the bank's requirement is, and they prepare a budget. So this IT organization prepares a budget and the timelines also. So what they do is like they prepare the budget. So to update your services, to create a software, to develop a software for your bank, this is a budget. Some X amount would be the cost for your creating, and some Y time it takes to prepare the software. When the bank gets an agreement with this, bank understands the budget, time, and they analyze and they think it's good. Budget is a very appropriate budget, and time is also okay for them. Then they get into agreement with the IT company. IT company to develop a software. So IT company and bank gets an understanding. So here IT company is a vendor and bank is a customer. Okay. So this vendor and customer get into an agreement to develop the software. So now for developing anything, developing a software means for doing anything, for working on anything, there should be some input and we get some output. So for getting an input and an output, we need to follow a process. Okay. So for example, if we take a paper or anything, we need some raw material, right? And like raw material would be paper, trees or waste papers or something, and they crush it and we get the output as paper. So here what? To get the output, we are following one process, right? Process. So we are giving some input, we are getting some output. So to do this, we are following a process. So here also in our IT industry also, if we follow the process of doing something, process of getting an output is called as SDLC. It means we follow certain process. The process of following certain things, certain rules, certain steps is called SDLC, Software Development Life Cycle. Right? So what is a process? So what are the steps? What are the phases we follow here in SDLC? The basic thing, one is requirements. So in the software development, first they go through the requirements and they analyze the requirements and then design. They design. The design is a sense of like high level architectural design, like flow. They contain flow charts, VSS sheets, plan what they need to design, how to design, how to develop a application. They all do design here. And next part would be the coding. So developers, they assign the designer after developing the architecture, they assign this to the developers. They do coding. After coding, they do testing of the application. So after testing of the application, they deploy it in live environment, deploying. Okay, this complete whole process is called as SDLC, Software Development Lifecycle. So here you see uh, requirement output is the input of a design. So design output is the input of a coding or a build, and coding output is the input for the testing part, and testing input is the output is the input for the deployment part. So following all these things is called SDLC. Here again, this testing part is having a separate uh, life cycle. It's a more crucial part in this complete SDLC part. So in detail we'll discuss here. So now we are now till here. Do you understand like what are the different phases we have in SDLC? Sorry, Ammar and Deepak. Good, nice. Okay, voice is too low. Okay, let me. So this is these are the different phases of SDL, software development lifecycle: requirements, design, code, testing, and deployment. So we are developing a product for the bank. Okay, now product we are developing. So what is a product? Now we need to understand in an IT industry, we very commonly, very regularly, we listen the terms of product and project. So what are these two actually? What is a product? What is a project? So when an IT organization develop a software for a particular purpose, for example, say this bank, they develop a particular software which is used for only by this organization, and this is not used, this cannot be used by any other organization, and this is called as project. So here in our IT industry, we listen two terms, project and product, or like we listen product based. Our organization is a product based organization. Ours is a service based organization. You hear the term service based organization. What is a service based organization? Service based is nothing but a project based. Service based or a project based organizations, both are same. So whenever we develop a software to a particular client, it is called as project. So whenever we develop a software based on the market requirements, based on the market requirements. So what exactly market is required? Market requirements. So based on the market requirements, we develop a product, and this product can be customized. See, for example, if you take Tally software, Tally is there, or Joho application is there. Some HR management tools or pharmacy management tools. Pharmacy management means in medical shops we see billing system, right? Billing systems. So these all are products because they customize them based on the client's requirement. See, I develop a software and I release in the market based on your requirements. See, Amar's requirement is like Maybe he requires only billing part. He doesn't require employees attendance part. And Deepak may require employees attendance part and billing part, all the calculations, inputs, outputs, taxations, everything he may require. So my software, my pharmacy software, which I developed, I will customize and I will provide you all these requirements based on your requirements. So market requirements, based on the market and based on the client's requirements, we customize it and we provide it. So customizing a product, customizing the software is called as product, right? So what are all, for example, you can hear TCS, Wipro, or Cognizant. These all are service based organizations, service based IT companies, because they develop and they do support for the organizations. So why they go live, why are this called service based? Because means, see, now this IT company has developed a software provided to bank for online services. After a couple of months or 1 year, 2 years, this bank wants to update its service, and in meantime also they keep supporting to this bank. Ask like if this bank is getting any issues, any production issues are there, like when they do open an account, maybe some issues they may find which were not found in testing part. Means like there would be certain issues in our regular life of testing, like the issue we may not find 10 times when we do testing, 100 times when we do testing, but one not one time it may come. There is a big bug when we work for 101 time. When we do testing for 100 times, we don't find any bug, but 101 time there may be a bug. These are very rare cases. These things happen in these applications. So IT company would provide services for all those things. So that is why it is called service based company. In product based is like I develop a software and I give to a company. I dispatch it to the organization, and then what they do is like they keep working on it, and if they want to do some maintenance, the same patchworks, they may go to some other organization which costs very less for them. So that is the difference between a product based and project based. So TCS, Wipro, Cognizant, we see these are service based, and we can see IBM, Google, Microsoft. These all are product based organizations. Means like, see, Google initially they have developed Hangouts, then they have developed Google Meets. Okay, so they are upgrading based on the market requirements. Now Microsoft, initially it was Windows 7, 6, 5. Now they have come to Windows 10. They are upgraded. Internet Explorer is there. Now they are upgraded to Microsoft Edge. So based on market requirements, market what customer is thinking, what people want it, based on their requirements, they keep updating this one. They keep releasing to the market. So this is called. So these are product based organizations. Okay. Any questions, any doubts in product based versus project? Okay. So now we have seen what is software, what is SDLC, what is project versus product. Now we see basic testing principles. There are some testing principles are there which we need to understand. See, these all are not required for any interview point of view or anything. Nobody is going to ask you in interview what are the testing principles, but which we need to understand while we are doing the testing. So where these testing principles help is like for not getting panic. See, now when we are doing testing, we are at last we are humans, right? We are not God. So we don't give a product 100%. So we should not get a panic if we found a bug in uh, production. So when we find a bug in production, we should not get panic. So for that, we need to understand these principles. So what is the first principle? First principle is testing shows presence of defect. We need to understand if there is a requirement of a testing, it means that there is a presence of defects. That is a basic thing. Exhaustive, second principle is exhaustive testing is impossible. Exhaustive testing means, see, we are humans. We don't test each and everything. Pin to plane, everything cannot be covered in testing. We try to cover maximum. But we cannot cover everything. For example, today, if you see Mahindra and Mahindra's website, uh, uh, bikes and cars delivery website. So they have an error, content error. They in that website you can observe Telangana spelling is a mistake. So it means like 100% everything is not possible. Everything is not possible to cover in testing. So exhaustive testing is impossible. We need to understand. Third principle is early testing. Early testing means before we divide our work into different testing in the team to different test QA engineers and we start working, we need to do a sort of early testing. Early testing is nothing but it's like a smoke test, we can say, or like a sanity test, not exactly, but similar to. So what this early testing is doing, like when application is ready, we just go through, we just have a rough testing one round, like we just navigate through all the pages and see nothing is crashed. See if any page is crashed. For example, we log in, we go to home page, we click on we select an product in e-commerce website in Amazon, for example, and that is dropped in the cart. We go for billing, we do billing, and we do the payment. So while doing so, if there is a crash while doing the payment, the page has been crashed or the application is crashed, then there is no point of working on all other pages. So we can find in early that there is a very big bug which need to be fixed, and they do it. Defect clustering. Defect clustering is nothing but it is like major part of defects lie in small parts of modules. So we need to understand that small part of defects majorly lie in small modules. So we need to be very thorough when we do a small parts of testing. And pesticide paradox. Pesticide paradox is nothing but it's like when we, for example, if we say we take a combiflin tablet for pains, and if we keep on regularly taking that tablet, after a couple of years, years, the tablet doesn't work on us. It says that it don't work because it been adjusted to our body. Same way, pesticides, if we use the same pesticide, keep on using for years together on a farmland, after a couple of years, if that pesticide don't work, it won't kill the pesticides, insects, worms in the thing. So in the same way, pesticide paradox, how it work in our testing is like, if you take a test case and if you keep on executing repeatedly same, we don't get any output because repeatedly over and over again, if you keep on executing the same test case, we don't get any new result, right? We need to update the test case and we need to try in a different way. And sixth one is testing is a context dependent. Testing is a context dependent means at the end of the day, we are not the deciders. We need to depend on somebody. See, as I said in our this one, see, testing has many inputs. We need to get the code built from developers, requirements, design code. We all depend on these things. So we are not an independent one. Okay. So that's one important thing we need to depend. So mistakes may occur anywhere. Our duty is to find out, but at the end of the day, we are dependents. And last but not the least, and very important point we need to understand is absence of errors is a falsy. Falsy means there is there is no product without a defect. But their severities, their priorities may differ, but there would not be any product without any. If anybody say our product is 100% bug free, it is a false. It is a very false one. As I was saying in my demo class, for example, if you take one example which was recently happened, uh, uh, Tesla cars manufacturing industry. So they were manufacturing cars, right? You all know. So one person want to buy a car, and he was ordered online. He paid the amount and he tried to enter for booking the car. Due to some low bandwidth of internet issues or some fluctuations in internet or something in the low accessibility of the website, he has pressed the button 200 times. Recently, news this was there. So the order has been taken 200 times, and Tesla cars are delivered 200 cars to that home. How big fault it is. That much big or world's number one cars manufacturing industry has forgotten the small thing. So that is the biggest mistake what Tesla has done. So that fault has been come missed in testing. In testing part, we don't take out our internet and we try. Sometimes we may try, but based on applications severity and applications requirements, we don't do such things, but it happens. So these things in production we can find out lively when we get something. So these are some basic principles what we need to understand while doing testing. So clear here till here? Uh, yeah, Amar, as you are saying, IBM is into service based also, but IBM's main is to develop products. It keep on developing products for example, AS400, for example, mainframes. There are many other products. See, even Microsoft is into service. Google is also into services. But the major uh, company's role is for developing the products. Even TCS, Wipro, they do develop products, but their main principle of developing is software for service-based organizations. So this is something about testing principles, what we have covered in our demo class till here. So clear till here? Any questions, any doubts? Okay. So let's go to our next part of testing. So what are different types of testings actually? So now we have understood what is the software, what is the process of developing a software, what is the project versus product, service-based organizations, what are the basic testing principles, but what are the different types of testing? Different types of testings. Why these many types? So for this, in an organization of developing a software, two teams are major important. One is two persons are major important. One is a developer, who is also called as a programmer, and the other is a tester, who is also called as QA. Okay. So what this developer do is he write a piece of code. Each developer they prepare some piece of a code, and they do testing for their piece of code only. They don't do others piece of code. So they do their piece of code, and The piece of code which they have written and the piece of code which they are testing is called as unit testing. Okay, so a developer who do testing on their part and what they do is called as unit testing. So when developer does develop the program, testing part is done by tester. Okay, so developer develops a piece of code and he does testing. It is called as unit testing. And see, one unit means one piece or one part or one program or a piece of certain piece of lines of code what he develops. So each programmer do some piece of development, right? And when we do integrate all this, when we do join all this and do testing, it is called as integration testing. Integration testing. So this one is also done by developer. Okay, so they join all those pieces and they do testing. Okay, so till here developer has done some unit testing, developer has developed some joins and integration testing has been done. So what about QA then? So these developers, the piece of code what they have developed, they release to QA. QA in the form of a build or an executable file. Executable file. Okay, why executable file? So why this build? Why an executable file? Because a QA doesn't need what the program is, in what code he has written. So QA tester doesn't require what language, what program, uh, what code he has written. So we don't go deep into the, we don't look into the code, right? We just look into the application. See, now I'm going to, a developer has given me a testing, developer has given me this website to test. So I go to this website, I just log in, I do check whether all these functionalities are working or not. But I don't go deep into all the other things, right? What code he has written, how he has written, those are all not required. So they give for us in this build or executable format. So when they have given this build in executable format, we do testing. Okay, what we do, we test the complete application, a complete application or the part of application what we have given to us, we'll do testing. So that testing what we do, what a tester will be doing is called as system testing. So the testing what the testing what the QA do is called as system testing. The testing or the developer do is called as unit testing and integration testing. Okay. So now we have done testing. So this tester in testing part, what they do, even we have lot of activities. Like we do prepare test cases, test scenarios, test scenarios. So what are all these test execution part? What are all these? I'll explain you in detail in coming classes. So test cases means like it's a action part what we do. Action, some action what we perform. For example, if you take a login functionality is there. Okay, we need to log in. So what are the steps we perform to log in? So one is first step is to log into the website. Access the URL or a website link, and next enter the user ID, click on the login button, enter the user ID, enter the password, click on login functionality or sign in functionality, and then see that we are navigated to home page. So these piece of steps what we prepare are called test cases, and when we execute that, those are called test execution part. And when they are passed, positive test cases, uh, that application is being passed. So here we write both positive and negative test cases. Those all I will explain you in our coming classes. So coming here, again coming back to here system testing. So a QA, what he do is called a system testing. So unit testing and integration testings are done by developer. Okay, so combined this unit testing and integration testing are called as black box testing, and this system testing is called as I'm sorry, unit testing and integration testing are called as white box testing, and the system testing is called as black box testing. Why? This white box testing means they have code in front of them. They see, they do debug. They debug the code, and debugging means they in the code they give certain inputs and they keep on executing each and every line. So, for example, login, they give the user ID here, and they press F5 or F8 in their system, and they see it is going to next line asking for password. Again, they see the next line it is going to sign in button. That line is navigating to sign in button. Again, they see it is going into clicking on the sign in button and navigating to home page. So they see the code and do testing. So they have something in front of them, that is called white box testing. Whereas when coming to QA, they don't have anything. They just had an application. That's all. Now they want to do the testing. So see, for example, like I have given you an application to test. So for example, like I have given you this application to test, Myntra.com. So you go into this site and I said you to test. You don't have any code here. You just navigate here. You click on this men's module and you check here and see whether this is working or not. So since you don't have anything other than the application, this is called as black box testing. Clear here? So system testing is called as black box testing. Unit testing is called as unit testing and integration testing combined together is called as white box testing. Okay, white box testing. We have learned here what is white box testing, what is a black box testing. In detail, I'll explain you all those things in coming classes. Okay. Any questions here? Okay, so the combination of this means like white box testing and black box testing together are called as gray box testing. Gray box testing. So I'll explain you. So in our software testing, see, software testing, we have two parts. One is static testing and other is dynamic testing. Static testing and another part is dynamic testing. Next, under this dynamic testing, we have learned two things now. One is unit testing. We have learned what is unit testing. Unit testing, which is done by developer for the particular unit what he has developed. And then also we have seen integration testing. Integration testing. This integration testing is nothing but joining two parts of multiple units into a single unit. Apart from this, we have learned what is system testing. System testing. So apart from this system testing, there is one more testing called UAT testing. UAT testing. UAT testing is nothing but user acceptance testing. UAT testing. Okay. These four all together are called as dynamic testing. Okay, unit testing, integration testing, system testing, and UAT testing. So what is UAT testing is nothing but it is a process of testing conducted on the application in user like in production environment. Like in UAT there are two types. One is alpha testing, beta testing. In the environment where we do in development premises, which is similar to production environment, is called alpha testing. And when we do the testing in live production environment, it is called as beta testing. So basically UAT, user acceptance testing, is a process of testing that when we connect it on application, whether the application is ready for use or not. So this UAT testing is done by domain experts or SMEs, subject matter experts. They do this UAT testing. Okay, coming back to our this one. So unit testing and integration testing are called as black box, white box testing. And system testing and UAT testing both are called as black box testing. Okay, and combine of these two, black box testing and white box testing, are called as gray box testing. Okay, so unit testing, integration testing are called as white box testing. System testing, UAT testing are called as black box testing, and black box testing and white box testing are called as gray box testing. Okay, so this is dynamic testing. So what about static testing? In static testing, we have nothing much to learn in static testing, but the major point is like reviews. What we have here is reviews. So static means we don't do any coding or we don't do any testing part here. We do reviews. So one part is reviews. Here in this reviews, there are different types of reviews: management reviews, technical reviews, formal reviews, informal reviews. This is one type of static testing. Static testing, we have reviews and walkthroughs. Walkthroughs is another part. So what is walkthroughs? What is static testing details? I'll explain you again. Walkthroughs. Okay. So in short, it's a process of verifying are we developing the right system or not. So what is the help of this reviews is like whether the we are whether the developing product is right or not. They keep on reviewing. Management reviews means management conduct the top level meetings, monitor the project statuses, and they find out corrective actions if there is any slippages or not. What is a slippage? What are all? I'll explain you in coming classes. Technical reviews. In short, so one is management reviews. Another is technical reviews. This is technical team will do this technical reviews. Technical team will do this reviews. Means like they verify whether the development, whether the testing part is being done correctly or not. And next one is a formal reviews will be there. And next is informal reviews. So formal reviews means like based on the proper plan and documentation, whether we are following all the documentation or not, they will just review. And informal reviews means that is what we do in our regular daily stand-ups, code reviews, peer reviews. These all come under informal reviews. So in detail, I will give you notes and I'll explain you in detail again when we come into SDLC, software testing life cycle. I will explain all these things again. Okay, for now, just have a knowledge on what is the software testing. In software testing, we have two types: static testing, dynamic testing. In static testing, we have reviews and walkthroughs. So in reviews, we have management review, technical reviews, formal reviews, informal reviews. When coming to dynamic testings, right here. So what are different types of testings? So coming software testing. In software testing, static testing, dynamic testing. In dynamic testing, unit testing, integration testing. Next, system testing, UAT, user acceptance testing. So these two are called as unit testing and integration testing are called as white box testing. This system testing, UAT testing is called as black box testing. Okay. Combined of 1 and 2 are called as gray box testing. Okay. And this static testing, in static testing, one we have reviews. So in reviews, we have management reviews, we have technical reviews, we have formal reviews, we have informal reviews, and second one is walkthroughs. Okay. So static testing, dynamic testing, walkthroughs, dynamic testing, unit testing, integration testing. So this is about software testing. So in detail, when we come to testing, software testing life cycle, I'll explain you all these things. What is software testing? What is system testing and all those things, and different types of system testings. All those we'll cover in software testing life cycle. Okay. Clear till here? Any questions? Any doubts? Okay. Now we'll see Now we'll see SDLC part. So in our this one, we see like SDLC phases and models. So SDLC phases we have discussed. One is requirement phase, another is design phase, coding. This coding phase is also called as build phase. So anything can be called. Next is testing phase. And next is deployment or implementation phase. Okay, so here when I'm explaining these things, yeah. Okay, so here when I'm explaining this phase, this one, so this is the SDLC part. Okay, these 5 are the phases. SDLC, software development life cycle. So clear, right, till here? So in software development lifecycle, these are the different phases what we go through. Requirement phase, design phase, coding phase, testing phase, deployment phase. So we are not considered much about all these phases because requirements, that is the client provides the requirements, customer provides the requirements to the vendor. So vendor then designs this one and then they go to coding, developers develop this one, and the part is they give to testing. So we are more concerned about testing part. Deployment is like going to live production. So these are the different phases of uh, software development lifecycle. So this is one important question in testing. Do you know? Do you, for tester they will ask, do you have an idea of what is SDLC? So how you need to explain this one in our interview? In an interview, if they asked what is an SDLC or what. See, one thing you need to understand, you need to keep in mind is like in interview, if they ask you a question, in any interview, not only in testing or in, if I ask you a question, I'm an interviewer, I'm asking you what is SDLC. So you need to say SDLC means it's a software development lifecycle. It's a process of uh, having different phases to develop a software. So it consists of different phases like requirement phase, design phase, code or build phase, testing phase, deployment phase. In requirement phase, they get the requirements, and in design phase, architecture designs the design of the software, how they need to do. And in coding phase, developers develop the code, they build the code and deliver it to the testing team. And in testing team, they do testing of the complete software and they find maximum bug free product. They try to give quality product and then they deploy the software in live environment. So this is a complete process of software development life cycle. You need to say. So if an interviewer asks you what is SDLC, if you say SDLC is a software development life cycle, it's a process of different phases. And if you stop there, you think that you don't have any knowledge, especially when you try a job as an experienced person. You need to explain in a practical manner rather than in um, dictionary or bookish knowledge. So your explanation should be more on practical. Means like expression is more important than explanation. Means the interviewer need to understand that you have a knowledge of a technical or practical knowledge you have. You are not a bookish. You did not come to interview by just batting the uh, definitions of the complete thing, right? So you try to practice in explaining in your own language, in your own words. I give notes to you. Most of my notes would be in general practical mode only. So If you read that, that would be good. But I'm saying you try to explain him in your own words. And the second important point in interview is you should keep on explaining the topic what he has asked. You should not stop anywhere till he says stop. Means if I interview asked about SDLC, you need to explain what is SDLC, definition of an SDLC, abbreviation of SDLC, and different phases of SDLC, and what each phase will be doing in SDLC. So you keep on explaining till he says stop and or till he goes to next question, which which makes an impression that you have knowledge, you have an working experience. So this type of explanation will always help you, and it covers, and especially when a question which are much more aware, means you have more knowledge in SDLC, you keep on explaining, so that it will imply that you have a good knowledge, so you have practical knowledge. But you see, everybody don't have a good language of explaining in English, but the process of trying to explain is more important. The words you add here and there, the words which you keep in your explanation are more important. Requirement, design, build, testing, deployment, these 5 words are important, and remaining all how you frame is not important in interview, right? Clear? Okay, analysis part. So analysis part means when coming to testing part, in tester perspective, we have analysis part in testing lifecycle. Software testing lifecycle is there, where we do have different steps: uh, requirement analysis, test design. There also we have requirement analysis, test design part, test case execution, execution part, uh, defect part, deployment part. So in I'll explain the analysis part, requirement analysis, and there are different types of analysis, how we do BRS, business requirement specifications, software requirement specifications, functional requirement specifications, documents would be there. So those all I'll explain you in analysis part, all those things in STLC, software testing lifecycle part. Okay, clear, Amar? Okay, now we have gone through this different phases of SDLC. Okay, fine, good. We have different phases. We have learned it. Different phases of SDLC. Requirement phase. See, I keep on repeating these things, basic things multiple times, because they need to enter into your mind. These are very, very important. Okay, don't think that I'm keep on saying the same thing multiple times. Requirement phase, design phase, build code phase, testing part, and then deployment or implementation. Okay. Next, what are the different methods? Okay, different methods of SDLC. So clear till here? Any questions? Okay. SDLC. Different methods. Here in SDLC, there are different methods how we do this one. So I will explain you each one. Different models we call here. Okay. So any questions can ask me here. Sequential model and iterative model. In sequential model, we have two types. Waterfall model V model. These two are very key, very star marks, very important, and must questions in interview. So in incremental model, this is one model, rapid action method model, rapid action model, and the next one, prototype model, and third one, spiral model. Okay, so in SDLC we have two types of models. One is sequential model, and other is incremental model or iterative model. So in sequential model we have two types: waterfall model and V model. And in incremental model we have three types: rapid application model, and prototype model, and spiral model. So uh, this waterfall model, V model, I'll explain you tomorrow. Okay, and coming to this one, rapid application model. So before that, the sequential models. So what is the sequential model? Sequential model means like this model will be suitable for very small size of projects or activities. So when the project is very small size, we can use the sequential model as waterfall model or V model. And when the application is very large, very bigger size, we divide that one into different types, different parts, and work on it. So for that, this is incremental model or iterative model. Okay. So Deepak, what is this? No, no questions. All right, thank you. So here we have seen SDLC is having two models: sequential model and incremental model or iterative model. In sequential model, we have two types: waterfall model and V model. In the incremental model, we have three types: rapid application model, prototype model, spiral model. So sequential model is used for small size projects, and incremental model is for very big or large size projects. Okay, so waterfall model, V model, we'll discuss tomorrow. Now we'll see this one. So rapid application model. So what is this rapid application model? So in rapid application model, what we do is um, we if there is a project, for example, this is a very big project. Consider we are doing a project for ICICI Bank. Okay, so how big it is? So for doing a project for ICICI Bank banking sector, we cannot do it in a small method. Like we cannot keep only 10 developers or 15 developers and do that much a very huge project, right? So for that, what we do is we have we have made this project into multiple parts. We have divided this project, this big project, separated into multiple mini projects, multiple mini projects. So, like this. Okay. Multiple mini projects. So here so we have each one module 1, module 2, module 3. Okay. And um, module 2, module 3. So what is the advantage of doing this one like this? So here in this rapid application model, what they do is this module 1, module 2, module 3, in each module, they perform all the phases of SDLC. So can anyone say me what are the different phases of SDLC? Jaya or Amar, Mohan?
Sorry, what?
What are the different phases of SDLC?
Requirement, designing, coding, deployment, testing.
Yeah. So after testing, deployment should come. Okay. You should say
Yeah,
when you
before
say,
deployment.
yeah, you need to say in a process. Okay, because before deployment, testing should come. Yes. So design phase, requirement phase, design phase, coding phase, testing phase, and deployment phase. Requirement, design, coding, testing, deployment. So in each module, these all steps will come. So these all steps will come here also, here also. How many modules we have created? In all modules, we cover all this SDLC process. Complete SDLC process is being covered in each one model. Each one model. Okay. So this is called as rapid application model. So in this RAD model, a big project is divided into modules, and every module is considered as a small project or a mini project. And in each module, we will implement all the SDLC steps, all the SDLC processes. Clear? This is rapid application development model, RAD model or RADM or RAM. Okay, rapid application development model, right? Right. So next already we have completed. Okay. Next one in this one is prototype. Prototype. What is prototype? Anyone have any idea what is prototype? So prototype is nothing but a sample piece what we develop. Yeah, a mini working model, right? Exactly, a mini working model. Like when we want to do a big project, we develop a small prototype of the product, and we see it is working. It was as the expectations of the requirements as a client. So what we do is like user requirements would be there first, and then we develop the prototype. Okay, develop the prototype, and we give here for verification to the client. So based on this verification and this prototype development, they develop the business requirements. Means uh, they prepare a SRS specifications requirement document, and they verify that, and from here they do remaining steps of design, coding, testing, and deployment. Okay, so we do the prototype. We based on the prototype, when the client is accepted, based on that we do the we follow the remaining processes. So here one bad thing is like in any stage the requirements may change. Any stage the requirements may change in this prototype model. Change requirements, right? So in after deploying also, or at the time of testing, at the time of coding, the requirements may change, and again then we go to SRS, they verify, they prepare new SRS, and they design and code it. This is a prototype. Second model of incremental model, prototype model, right? And next model is spiral. Spiral model is suitable for actually for maintenance projects. It is very suitable because here the requirements keep on changing very frequently, very frequently. When the requirements keep on changing, they go for the spiral model. So what this spiral model is like, so like this it will be, and see here, yeah, like this, right? Okay, so we plan, we analyze, we create the specifications, we develop, and we do risk analysis, we do execution. See here at the last part of risk analysis, when we do risk analysis, if you find anything, again we come back to here, starting point. See, this is a starting point. Okay, like this it is rotating. Okay, and again we go to the starting point. We do planning, we do verification, we do execution, we do risk analysis, and again if you find anything, we go to starting point. So So the requirements keep on changing here very frequently. That is the reason this is called a spiral model. Okay. So what are the different models we have? We have sequential model. In sequential model, we have waterfall model and V model. In next one is incremental model or iteration model. In here, in iteration or incremental model, we have rapid application development model. We have prototype model. We have spiral model. So rapid action development model, we keep dividing the big project into multiple models, and in each model we implement all the SDLC process. Complete SDLC process is implemented. In prototype, we develop a sample piece of software or a mini project, mini software, and when it gets approval, we keep developing the original software. And then when you go for spiral model, we use this because when there's a frequent change of requirements, we go for spiral model. Okay, any questions still here, anybody? Prototype model, I have explained you, right? Before spiral model, I have explained prototype model. I have given okay. So okay, I'll explain you again prototype model. Prototype model, I have prototype. See, I have written here user requirements. Okay, in user requirements, we develop the prototype. Develop prototype, and we verify it. Okay, after verifying it, SRS, we prepare SRS, we get approval for this SRS, and then we do design, coding, testing, deployment. So the bad part of this one is, like, at any stage there would be requirements change in requirements, and again we do approval, get the approval of SRS, we update the SRS, and again we keep working on this if required. So this is the prototype. So all the SDLC activities will be carried based on the SRS, software requirement specification document. If any changes are requested by the customer, means like after delivering the system, again the same document will be approved. So after we developed and deployed, the customer request for any changes, what we do is we create a change request and we update the software requirement specification document, SRS document, or system requirement specification document, and again if required we'll perform all the cycles. Yeah, so how can we explain an interview? So most of the time if they ask, for example, what are the different models of this one SDLC, you keep saying like there are two types. One is sequential model, non-sequential or incremental model. In sequential, waterfall, V model, incremental, This one. If they specifically ask what is prototype model, so prototype model, this model is recommended when the application size is big and the customer requirements are not clear. Okay, so we can say that for prototype application size is big and customer requirements are not clear, we create a prototype. As the requirements are not clear, we create a dummy application. Okay, you can use the word dummy. We create the dummy application and we demonstrate the dummy application to the client, to the customer. So once he satisfies with the dummy application and he feels like this is what he required, and then we prepare the system requirement specification document will be prepared, and then we do all the SDLC process from there on. Clear? Clear? Right. So Jaya, Deepak, Amar, Mohan, any questions? Jaya, do you have anything to say?
No, it's clear till now. I don't have anything.
Okay. Good. So Amar, for you? Mohan?
Nothing. Nothing ready.
Okay. So we'll end the class for now today. Okay. Tomorrow we'll be going through different sequential models, waterfall model, V model, and what is QA versus QC versus QE, what is quality, and who is the quality analyst, who is the quality controller, who is quality engineer, waterfall model versus V model. We have little description about this, and we also know what is verification and validation. Okay. We will discuss about this in tomorrow's class. Okay. Right. Thank you, guys. If anything, you can WhatsApp me or call me.
Okay.